Hello everyone, welcome to the channel. This is Akshat Mishra, and today I'll be uh, upsolving the question uh, in CodeChef Starters 74 which appeared. It's called Minimal Inversion problem, and let's read the problem statement right now. We have an array A which has a length of n, and chef performs the following operation on A at most once. Okay, note it down. We need to select two pointers L and R. Each element between these two indexes such that uh, we have to set them by incrementing them by 1. Okay, so each element which would be present between these two pointers L and R would be incremented by 1. Okay, and we have to perform one operation which is called inversion. What we have to select pairs I and J such that uh, J is greater than I, and the element which is present at ith index is greater than the element which is present at the jth index. So what the problem is trying to say that uh, what we mean by inversion, first we will see it through a test case. So the first test case which we are given is this one, 4 2 3 1 5, which has n equal to 5. You can guess it right from right here, and the elements in the array are 4 2 3 and 1 and 5. Okay, so the current inversion for the first element, which is 4, are the number of values which are less than it and appear towards the right of that index. So let's see it. What is smaller than 4? First thing is 2, second thing is I guess 3, and third thing which is smaller than 4 is 1. So total inversions for the value 4 are 3. The total number of values which are less than 2 and appear towards the right side of it are 1, and we get it 1. Okay, the total number of values which are less than 3 and are towards the right of it in this array is 1, and thus the frequency is also 1. So by summing all the 5, because we got 3 for 4, and for 2 we got 1 value, and for 3 we got 1 value. So total inversions which come out are 5. Okay, and since we were performing that set operation, what we are trying to do is we are trying to reduce the number of inversions to the least possible value. And how can we do that? We can just try to make more and more elements equal to the previous elements which appear in the array. For example, here we can choose the index number L equal to 3 and R equal to 4, where L equal to 3 is the element 3 and R equal to 4 is the element number 1, and increment them by 1, so that the array becomes 4 to 4 to 5. And now when we check our array, we will find that the number of inversions for the first element 4 becomes 2, because the two 2's are present here. So the number of inversions for 4 become 2, and the number of inversions for this 4 would become equal to 1, because we have only one element which is less than it, which is 2. So total inversions become 3, and the number of inversions which get reduced become 2. Okay, so I hope you understand. What we are trying to actually do in this problem is we are trying to uh, reduce the inversions by as much amount as possible. We don't exactly care about the inversions which would be present in the original array. Let's say the original array was B, and the inversions which were present in the final array, let's say we have final array has A inversions. We actually don't even care about it. What we exactly care is about, or the difference between these two is what we actually care about. Okay, I hope you understood it. So the one thing which is a catch in this problem is the index r can always be taken at the rightmost part of the array. Why we are doing it so? Because most part of the array, if because we when we set L to be, let's say, here at third index, which is L, actually greater than 3, and we don't have to find all the elements which are greater than 3. We for finding the difference, what we care about is the number of elements which are greater than 3 by a factor of 1. That is, we have only one element, which is 4. Okay, only 4 is greater than 3, so our inversions would become 1 for this case. And towards the right, we also need to find out the number of elements which are less than 3 by an amount of 1. For example, let's say if our element was 2, then towards the right of it, if we have an element which is smaller than 2 and by a factor of 1, which is 1 right here, then we would subtract that from our resultant inversion answer. Okay, so what we can do in this question to maintain these two things in the answer. So how would we solve this question is by maintaining two maps having, I think you know what is a map. It has keys and value pair. First we would traverse the array from the left position, and then we would traverse the array from the right position, and as soon as we find an element from each of these traversals, we would populate it on our these two maps. So I've already created the trav left, and we have kept the elements here, and the frequencies are stored right here. Okay, you can see 1 has frequency of 1, 2 has frequency of 1, 3 has frequency of 1, 4 has frequency of 1, and so on. Okay, so now what we'll do is we would traverse the array from the right, and also if we find an element from the right traversal, we would also reduce its frequency by an amount of 1, so that our elements do not repeat while we are counting our inversions. Okay, so when we are traversing from right, first we encounter 5. Okay, we get 5, and its frequency would be 1, and since we have found 5, then this one has no significance, it would be reduced by 1, it becomes 0. Okay, then we will find 1. Okay, so also for our answer we need to maintain two variables. Let's say first one is sum and second one is answer. So what we will do is as soon as we encounter an element, the element towards left, if there is any element towards left which is greater than the present element by a factor of 1, let's say we are currently at the index of this position which has 5, and if in this array towards the left we find an element which is 6, then what we'll do is we'll store down its frequency in our sum variable by incrementing it with that amount. Okay, sum would be incremented since there is no 6 present in the array right now, so currently it would be 0, but for future elements we would definitely find it. Okay, and towards the right of it, if we find an element which is smaller than it by an amount of 1, then we would decrement it by that. Okay, and in the answer what we'll do is we'll just store this sum every time we of the sum variable after each updation, maximum value between the answer answer variable and the sum variable. Okay, so we found the element 1, its frequency would be 1 here, yes it would be 1, and in the trav left map, so what we get right now is we would check if whether an element is present which is greater than it by a factor of 1 to the left. Yes, there is one, which is 2. So in the sum it would be incremented by 1. Okay, and since there is no element towards right which is smaller than it by a factor of 1, so nothing reduces here, and answer would have value of 1 here right now because we are finding the max value. And then we would traverse to the next element, which is 3, and yes, we have 3, its frequency would be 1, and here the frequency reduces by 1 to 0. Okay, the frequency reduces to 0 in the trav left map of the element 3. Okay, so an element is present actually which is greater than 3 by a factor of 1, so in our inversion it would be incremented by 1 and it would become 2, and since 2 is greater than 1, so in the answer inversions also it would become 2, and then we will in the traversal we will find the next element, which is 2, its value will be 1 in frequency, and here it reduces to 0. Now there's a catch here, there was a value here which was in the right which is smaller than it by a factor of 1, which is 1, so the sum inversion value or current inversion value would be decreased by 1, and so sum would now become equal to 1. Okay, and since the answer inversion variable already has a maximum value from this sum, so it would remain as it is. Then we would traverse the final element of the array from the right position, which is 4, and 4 would be stored here, its frequency becomes 1 in the trav right map, and in the trav left map its frequency becomes 0. There is no element in the left, so there is no need to check it. There is an element in the right position which is smaller than it by a factor of 1, so we would reduce the sum variable by another 1. Our sum variable now becomes equal to 0, and answer is still greater than the present element which is s, so it would remain as it is. So the final number of inversions which are reduced would be equal to 2. Okay, and as you can see it has matched our sample output. So I hope you understood the problem through this example, and now let's see the code of it. Put of n, and I made two maps by first taking the array as input, and here we have the two maps. First we would populate the trav left map in its frequency table, and I have maintained two variables. First one is current inversion and second is max inversion. Okay, so what we will do is we would loop through the array from right traversal and the trav right map would be populated every time we encounter an element, and every time we encounter an element from the right traversal, we would reduce its frequency in the trav left map. Okay, so in current inversion, if there is an element in the left portion of the array which is greater than the element by uh, with a difference of 1, then its frequency would be incremented in the current inversion. And if there is an element at the right of the current position whose which is smaller than it by a value of 1, then its frequency would be decremented from the current inversion. And at the end, since we have to find the maximum inversions, so we would find the max value between these two comparisons. Okay, so I hope you understood the problem, and as you can answer. So yes, our question was upsolved. So I hope you liked the video, and thanks for watching finally.